Python AMS. What is it? How does it work? And more importantly, is it better than the Bambu Labs AMS unit? I'm Aaron. This is the Printasaurus. Let's find out. The Python AMS is a departure from the standard design of the Bambu Labs AMS. HumeBeam has designed others, the Hydra and Hydra Pro, that are based on the internals of the AMS and also utilize the enclosure. The Python is a completely new design. Instead of it using the rollers, it is now using a gear drive system, which takes a lot of stress off of your feeders. It is supported by 608 bearings. It utilizes a spool holder or adapter that these spools screw onto, and they are fully supported by those 608 bearings that I mentioned. The modular based system looks like this. So you have multiple modules that you print. If you really wanted to, you could put two AMS units together. They are connected by these dovetail joints here, and they simply slide in place and click in, and you secure with a couple of screws. If you're looking for hardware, if you need printed parts, you can source those from Voxel here in the United States. They have partnered again with HumeBeam to provide printed parts and hardware. They are reasonably priced, so check out that link below. If you want to print your own parts, Makerworld and Printables have great profiles available. All of the instructions for assembly have been fantastic. They were easy to follow. They will be even easier if you have previously done a Hydra or Hydra Pro, because that really just gets you familiar with the removal process. I will drop a link below on the Bambu Labs AMS removal. This is what the Python modules look like. You print each of these individually, and they connect by these dovetail joints here. And once you have them together, you have quite a large setup. That setup ends up being 440 millimeters by 310 millimeters by 275. Your standard AMS unit comes in at 368 by 283 by 224. So there's quite a big difference in size. It still fits on top of your printer. So if you have, your X1 carbon or your P1P, P1PS, and you like to set your AMS unit on top, it still fits. It just takes up a little bit more space. It hangs over a little bit, 25, 30 millimeters on each side. So not a huge deal, but keep that in mind when you're looking to place this thing near or on top of your printer. You may need some more room. I did mention the Python being a departure from the standard AMS unit. It does utilize the majority of the AMS internals. The one thing it does not is the RFID. It does not bring that over to the new design. Not a big deal, guys. Part of doing this and the idea behind the Python is being able to run any spool type you want. So that means you're stepping out of that Bambu Lab umbrella and you're looking at other manufacturers for spools. The Python supports spool widths up to 80 millimeters and a diameter up to 210 millimeters. The standard AMS unit supports 68 millimeters at max and around 202 millimeters for overall diameter. A very nice feature of the Python is the ability to run your abrasive filaments. You can bypass the feeder completely, running a separate PTFE tube, and you can run those at all 4 feeders if you would like. In my current setup, I only have it at 1, but in the past, I've had to attach a separate spool holder or find a filament dryer that had rollers to where I could, kind of run the filament up through the dryer and then into the unit. Now you can bypass that completely and utilize the Python as a spool holder, and it's all in one. So no longer do you need those external attachments to run your abrasive filaments. That is awesome. I mentioned sourcing parts, and if you wanted to use Voxel, like I said, here in the US, they offer pretty much everything. Well, they do offer everything. You can do hardware, printed parts, the enclosure if you want it, but maybe you don't want to print anything. So what do? That's when you reach out to today's video sponsor, and that is PCBWay. So you can jump on PCBWay's website, you can upload all of these files, and say you wanted to print them in ABS or ASA, and you didn't really want to do that at home because you don't have a well-vented space or anything like that, well, use PCBWay. You know, they have the facilities, they have everything set up properly. You're not going to smell any of those fumes at your house because they're going to be somewhere else where they're getting printed. So check out PCBWay if you want to use them for the enclosure. They offer CNC services that you could use. You could print, or I'm sorry, you could CNC all of your acrylic paneling for the enclosure. If you want or have any other projects you want to do, you can get in touch with their support and talk to them about them. You can order multiple quantities. Easy process, easy website to navigate, PCBWay.com. Check it out. So something else the Python offers is an optional enclosure. And this enclosure is pretty unique because it allows you to add active heating. So you can actually make this thing a filament dryer, and it utilizes the Polymaker filament dryer that they just came out with. It is pricey to do it, but if you're looking at running ASA, ABS, and things like that, and you want them in a completely controlled environment where you're keeping all that moisture, those are hygroscopic filaments, so anything that takes on water, this might be a great option for you to have. So, covering a little bit of the assembly process. I'm really not going to go over too much of it because the instructions really are fantastic. But once you've got all your printed parts, what I suggest doing is starting with the middle two. So go ahead and mount your feeders on every module, and then assemble the middle two, and go ahead and do all your screws and attachments and everything, and then do your number 1 and your number 4. And the reason why I say to do that is because you can get in here a little easier when it comes to tightening things down and kind of getting things aligned. I found that it was just easier to work that way, or you can work one at a time. So start with number 1, get that one completely assembled, slide this in place, and then drop the feeder gear in place here and screw that in last. Speaking of the feeder gears, if you're buying the Voxel kit, they're gonna send you those in PETG. I recommend printing them in TPU. It gives you a little bit of dampening on the gear itself, which makes them a little less, you don't get as much noise. If you're gonna do this without the enclosure, it is loud because it's a gear-driven system, so you're getting all that noise, you're getting the feeder noise, and everything. So I found that it did reduce some of the noise using TPU instead of PETG for the small feeder gear. So keep that in mind when you're doing it. Yeah, so moving on to the next part, assembly. I didn't run into any snags. Pay attention to when you mount the main board. Make sure you have it in the right direction. That way you can get everything screwed in properly and actually clip all your wires back in place. If you do the Voxel kit, it comes with quite a bit of PTFE tube length. You will need to source PTFE tubes for this. Honestly, I would recommend going on there and buying the hardware kit. I think it's like 25 bucks, but it'll save you a lot of time, and you'll get all the bearings, you'll get all the screws, you'll get the PTFE tubes. Pretty much you won't need anything else if you're printing your parts yourself. So this is what your spool holder looks like. So you have this large gear here, and then that engages with the feeder gear that I mentioned we printed out of TPU, and basically you center your spool on and it just kind of screws in place. So you've got 2 portions that screw on the spindle here, So you have the inner insert. These are pretty, they're self-centering for the most part. You'll have to kind of get it close. And basically you just screw this in. Make sure your gear, or make sure your spool is centered on the gear, so when you place it in there. But just kind of get this snug. If you want to put a screw in there, there's a spot, and that just, you know, keeps some tension on the spool itself so it doesn't spin around. But I haven't had any issues with this moving. And then you just take this and drop it right into place. So we made it to the end. What do we think of the Python? Assembly was pretty straightforward. Instructions were great. HumeBeam does a fantastic job with all of his designs. Hydra, Hydra Pro, Python, great work. Really appreciate it and everything you're doing there. Overall, comparing the Python to the Hydra Pro, really like the Python. I like the gear-driven system. It just works better. It's smoother. I don't have to worry about spools and friction and the, you know, kind of getting bound up with the feeder from time to time. I like that it takes all of the weight off of the feeder and that roller assembly, being supported by those 608 bearings in the bearing races. And that's going to give you longevity with your feeder and some of the parts, which is always great. It's welcome. It's always good engineering when something gives you longevity. Also, I love the fact that you can bypass the feeders and utilize that unit to run your abrasive filaments. That's a big one for me because I don't always leave the external spool holder mounted because I'm always moving stuff around. So to not have to worry about that at all to run my abrasive filaments, that's big. Another thing that could really be appealing to you is the enclosure. So in my particular setup, I'm not going to continue to run the enclosure, but you know, having the ability to have the filament dryer, have it all in one, and then have the AMS unit inside of that, and then be able to utilize multicolor printing with your ABS, ASAs, and other filaments that take on that water, you know, that's cool. It's definitely the right way to do things, I think, moving forward. Some of these other companies are starting to come out. The Creality, I believe theirs is an active type setup, so it's not using you know, a passive setup like your desk tent and things like that. So it's cool to see these manufacturers coming out with this stuff, and you know, HumeBeam's design, it's right there with them. I think it's a good upgrade. What I suggest doing is run both, and what I mean by that is run a standard AMS unit, so you still have your RFID tags and all that good stuff, and you can run your bamboo filament and your smaller spools, and then have a Python as your secondary unit if you do have 2 units. I know not everybody can afford to do that, but if you have 2 units, run one of each, and then you can run any filament that you want. You know, you're not limited to just one spool width or one diameter. Now you can run anything you would like. And that's a big win. That's probably the biggest thing really with these designs. And I'm happy to see that people are really starting to put these out there. So good stuff. Appreciate everyone. Please like, subscribe, comment. Let me know what you think. Still working on the studio space. It is nowhere near where I want it to be. And to be honest, it has taken way too long to start getting some material back out. So happy to get something out to you. I've got a lot of cool stuff coming up. SV08 is coming soon. We're going to put that against my Voron. I've got some big tree tech stuff for the Voron. The little wireless screen that you can use to control everything. So look for those videos soon, and follow along for more content. It's coming.